Hi, and welcome to Gaming with EaselJS, an advanced Canvas course on Tuts+. In this lesson, we're going to learn how we can extend the base EaselJS classes and objects in order to create our own with their own methods and behaviors. While you don't have to exactly follow the structure I set out, when you're working on any sort of real-world project, it's absolutely a requirement to have some kind of structure. So let's get started. Open up your project folder in Sublime and the terminal. Start our terminal. And if you load up localhost 9001, you'll see what we had from our last lesson. We'll start off by removing all of that, and we're going to create a new class which extends an EaselJS container. So, when you start off a new project like this, it can be helpful to take a top-down approach. It can be good to think about how you want to be coding rather than just starting off coding right away. For example, if I want to add the hero of my game to the stage, it'd be nice to be able to just set up my hero like this. var hero1 equals new hero, give him a name to identify him, and give him an X and Y position to place him. Then I should just be able to add the hero to the stage like any other display object. So how do we create our hero class? Well, we'll start by creating a new file, save it as hero.js, and once again we can start thinking about how we want to code from a top-down approach. For example, it would be nice just to be able to create a subclass using some kind of helper method that we can make. We pass in the thing we want to subclass, let's say the EaselJS container, and we can pass in a string to give our class a name. Then we should just be able to pass in an object of methods for our class as well. So an initialize method and a fire method. In particular, in EaselJS, every one of their display objects has an initialize function. So we would want to be able to override that, but also call the inherited function as well. So let's have a think about this create subclass function. In utils, we can create a new file, create subclass.js. So our module is going to be exporting one single function, create subclass. Here's our function here, and here are the arguments we need to pass. We need to pass a superclass to inherit from. We need to pass a class name and an object of methods. So we're going to create a subclass and we'll be returning it. The first thing we do is set our subclass equal to a function. This function should immediately call this.initialize, and so that we can pass along any arguments that were passed to the constructor, we'll call apply with this as the context and passing in the arguments array. It's not technically array, it's an array-like object, but you get the idea. Now, one problem of writing it like this is that we can't actually name our function, which means we can't name our class. And when we're debugging, it may be difficult to understand which is which. We'll come back to a solution for that in a little bit. Firstly, though, we need to set the prototype of our subclass to a new superclass, and then we'll need to go through each of the methods in our methods object, and if that property is not a hidden or private property, we'll add that method onto the subclass prototype. We can now go to index of our utils and add create subclass. And in our hero class, we can require it. Create subclass and we'll require util/create subclass. Let's also create a shortcut to container, which is create.js container. And now we can create our subclass and export that class on module.exports. Let's start by adding in our initialize function. We'll decide on our arguments. We're going to have name, X and Y position. And then to set up our hero as a container, we need to make sure that we call container.prototype.initialize.apply and pass in this and the arguments. Container doesn't really take any arguments, but it's good practice to keep them there anyway. Then we can use name X and Y to set name X and Y on our new hero instance. If I save this and go back to main, I can now include our hero and we'll create an instance of it. Let's console log our hero here. We have found one compile error, which is one of the benefits of using something like Browserify. You'll catch these errors before you ever get to the browser. We've just incorrectly called util/create subclass rather than utils. Make sure we didn't do it anywhere else. Okay, so you can see our project is compiled correctly now. And we've got one more error in the browser this time. Hero $fire is not defined. I should just explain the reason I write my functions with the class name in front of them. It's really just syntactical sugar, but it does make debugging easier. Remember, we're going to have possibly dozens of different classes, and all of them are going to have an initialize function. By putting the class name in front of it, in the debugger you see exactly the class and the method name, not just the method name. So let's quickly create hero fire as a method, and that can just console log fire. So here you can see we've got our hero object being printed out. But notice what I said before, our hero is not correctly named in the debugger. Subclass. That's not really very helpful. If we go back to our create subclass function, we can fix that. Instead of creating our function like this, we're going to use eval to evaluate the same string but passing in a function name. Now don't let anybody tell you that eval is evil. That's just plain wrong. Eval is a tool, and like any other tool, it has its pros and its cons, and it has its correct usage and its incorrect usage. The main problem people have with eval are security issues, meaning you shouldn't be evaluating user input, which we're not doing here, and speed. Basically, when eval runs, it sets up a new JavaScript runtime to evaluate your code, and it can't be made to run more efficient by browsers like Chrome because the browser can't really predict what's going to happen in the evaluated code. The issue of speed is really not an issue for us in creating subclasses because most of your subclasses will be created at bootstrapping phase of your application. And on modern browsers, we're really talking about a very minimal difference anyway. If you really want, in production, you can switch off this line of code and put back this line, but I really don't think it's necessary anyway. So now, when we print out our hero, you'll see our hero is correctly named. It has inherited all of the functionality of a container, but also has our custom fire method added to it, which if we call in our main file, you can see prints out fire. Now from this point on, our hero class can then encapsulate all of its behavior. It can manage its own display objects, its own event listeners, and while we have our public API here exposed, we can even include private methods now by keeping them in the scope of this module. So I can call setup display, call it and pass in the context of the instance, and our setup display function can create a new create.js shape, set it to this.body so that we have a continued reference of it, and it can draw a green rectangle and add that to this. Remember this, the instance, our hero, extends the container class so it can add children. And there you can see our green square. Or I should say our hero. That's all for this lesson. Check back in for the next lesson where we're going to get started on creating a tile-based puzzle game. Ciao!